In today's lesson, we are going to explore combinations. Our goal is to explore how counting combinations differ from counting permutations. So we've got the School Athletic Council has 5 members: Emma, Ethan, Mason, Jill, and Joshua. This Wednesday, they plan to hold a bake sale. We want to show all of the possible committees of 2 people that can be chosen to sell the baking during lunch. So if you want, take a minute and pause this video and try and write out all the possible committees of 2 people that can be chosen to sell. So what that means is we might choose Emma and Ethan. Maybe we choose Emma and Mason, etc. So go ahead and pause this and try to write out all of the possible combinations. So here is what we get. We have 10 different ways that we can choose the 2 people. What do you notice here? Or do you notice anything? In our first pick, we picked Emma and Ethan. Anywhere did we rearrange it to Ethan and then Emma? And the answer is no. Here's where we started with Ethan, and there is none that have Emma as the second person. And why might you have that? Well, you need to think about this. We're picking committees of 2 people. Does it matter who gets picked first or second? No, they're just 2 people that are going to sit and sell the baking during lunch. So what do you notice? This is less than if the order mattered. If the order mattered, we would have had all of these reversed in order as well. So when the order doesn't matter, we're going to have less options than if the order did matter. A combination is a grouping of objects where order does not matter. For example, the 2 objects A and B have one combination because AB is the same as BA. So here is where this outcome becomes challenging. You need to be able to sort out in your mind in the question whether or not it is a permutation where order does matter, or whether it's a combination where the order of things does not matter. So if we go back to these ones, when we are choosing the committees of people, were these committees a permutation or a combination of people? Well, each committee is not a permutation because the order in which they are chosen does not matter. What matters is whether each person is chosen or not. Each committee is considered a combination of people. A 2-person committee of Emma and Ethan is the same committee as Ethan and Emma because they both include the same 2 people and both exclude Mason, Jill, and Joshua. So this was a combination. So now we want to look at what's the different committees if 3 people were chosen to sell. So this time we're picking 3 at a time. So I might choose Emma, Ethan, and Mason. Or maybe I'm going to choose Ethan, Jill, and Joshua. So again, take a minute, pause the video, and see if you can determine how many different committees of 3 people we could have. So if we look at this, there are still 8 different combinations when we choose 3 people. But again, because this is a combination, there are less options than if we were ordering these. If we were ordering these, there would be many more options to consider. Because that first grouping of Emma, Ethan, and Mason, we would have to rearrange that to be Ethan, Emma, Mason, to be Ethan, Mason, Emma, Emma, Mason, Ethan, and then put Mason at the front with different combinations. There would be a lot more if we were ordering it. Now I want you to see if we had 4 people that were chosen to sell. So how many different committees could you make of 4 people? And again, go ahead and pause the video and see if you can list all of the different committees. As you can see, there are only 5 different committees we could have where we're choosing all 4 people. So we're getting less in our numbers here. So what do you wonder? When you look at this, and when we started by just choosing 2, or when we chose 3, or now we're choosing 4, what kind of questions do you have? And there's lots of different questions that you might have at this point, things that you're wondering. For example, maybe you're wondering, is there a relationship between what we've done? What is the purpose of this? Why does it get less as we choose more? So as soon as we chose 4 people, there were less combinations. What would happen if we chose all 5 people? How many groupings would we have? So those are some questions you might be wondering about, and you may have more. It's all about thinking about the problem as we go through in solving it. So the expression 5 factorial divided by a factorial b factorial can be used to determine the number of committees that can be formed from 5 people. What do you think A and B represent in this expression? Then we want to verify that this expression works for all of the 2, 3, and 4 person committees we considered. So let's think about this. Do you have any ideas on what the A and the B might stand for, first of all? Well, if maybe the A stands for how many people are chosen for that committee. And then the B is how many people are not chosen for that committee. Let's see if that works. So when we chose 2 people, we would be saying we chose 2, and that means 3 we did not choose. And when we solve this out, we get 10 different committees, which was true. If we go back a couple pages where we chose the 2, there were 10 different options, 10 different combinations. So let's check this for the next one. Let's say we choose 3 people for the committee. Then there's 2 people that are not on the committee. We do this calculation, we get 10. And it should make sense. Look at what we're dividing by. Multiplication does not matter what order we do it in. So 2 factorial, 3 factorial is the same as 3 factorial, 2 factorial. And when we chose 3 people, there were 10 combinations. So that one is verified. Let's check the 4 person committee. 5 factorial, so we're going to choose 4 people. That means 1 person is not chosen. We get 5. Let's go back and have a look. There were 5 different combinations when we chose 4 people. So we verified that that works when we say A is how many people we're choosing and B is how many people we're not choosing. Now let's suppose we're only going to pick 1 person for the bake sale. How many ways are there to pick that 1 person? Now we should know there's 5 different ways. There are 5 people. We're going to choose 1 of them. That will occur 5 ways. So let's see if the expression works. 5 people. We're choosing 1. That means 4 are not being chosen. We do that calculation and we get 5. It does work. So this expression here must be leading towards something. And what do you think it might be leading towards? Maybe potentially a formula. For now, let's just think about this. When order does not matter in a counting problem, you are determining combinations. All right, so when order is not important, you are doing combinations. When all n objects are being used in each combination, there is only 1 possible combination. All right, so that would be, we didn't look at this one. We have 5 people. We are choosing all 5 people. 0 people aren't being chosen. Remember, 0 factorial is equal to 1. 5 factorial divided by 5 factorial is 1. So that does work as well. So if you are using everyone, if we say we have 5 people and we want 5 people working, there's only 1 way that we can make that choice. And then from a set of n different objects, so let's say 5 different objects, there are always fewer combinations than permutations when selecting r of these objects when r is less than or equal to n. So what we're saying, if there are 5 people, as long as we are choosing 5 or smaller, which we would have to, There will always be fewer combinations than permutations.